Willkommen zurück bei Insight Junction, dem Kanal, den Sie abonnieren möchten, noch bevor der Gastgeber es will. Aha! Sorry the bot was on the wrong language. Hello everybody. Welcome back to Insight Junction, the channel you would like to subscribe even before the host asks for. In this second video, we are going to test the limits of some AI bots. This video will also contain professional jobs made by other people. Why don't we start then? The first bot we can use for image generation is Dall-E from OpenAI. You could just write to the Dall-E for its job. Before, however, OpenAI made a good decision like adding an image bot to a language model, GPT-4, that gave us the possibility to explain ourselves better and have better product. Honestly, at first I did not want to make it too complicated to not take my expectations too high, but it surprisingly made me congratulate the intense work of OpenAI. I wanted an Elon Musk caricature, and the result wasn't very satisfying. Although the idea was good, the face did not look like Elon regardless. Then I asked for kind of a joke, a Stephen Curry as a bowl of curry drawing. And before wanting more serious ones, this was well made. Here is the aforementioned picture. It wasn't bad, I gotta agree. I just wondered the own creativity of bot and asked for the most random image they could generate ever. After I saw the result, I was impressed. From another tab, I said this was created by an artist and asked what could it mean. Here is the explanation. Of course, I wasn't involved about the explanation, but containing all these details in one image with a good quality made me understand it more and more. I was underestimating the potential of this bot. If drawings were good, schemes had to be much better, considering this is a language model. I wanted a scheme of an industrial explosives production facility. They handled it expertly. I wanted a design for the team I support. They handled it expertly. I just could not find a mistake. But then suddenly, the idea came to my mind. Texts. Yes, you heard it right. Texts. Despite its language model personality, it could not be good in everything. It could fail in writing texts on a drawing because it was designed to draw everything it does, not write on it. While it draws the letters, there could be problems. What I wanted next was, the slope stabilization technique for road construction is depicted with an illustration showing the drilling process at a 120-degree angle to the surface. The use of a rock drilling machine, the placement of iron reinforcements into the drilled holes, followed by concrete injection to secure the slope, is emphasized. This detailed depiction clearly represents the angle and method used for slope reinforcement. The word nitrol has been added to the illustration demonstrating the slope stabilization technique. The word is prominently displayed next to the rock drilling machine or in the scene, seamlessly integrating with the detailed description of the slope reinforcement process. Before showing the results, I want a promise. You will not ask, why do I need this image? If we are agreed, we can check the impressive image with this minor mistake. I knew it! It could not process the letters completely correct. However, the work was pretty good. We just need, ooh, yeah. Now that feels good. As you see, image generating with AI may have some issues. However, when we see the bigger picture, it is so much more than we could even imagine. And the problems are pretty solvable, though. A language model is probably good at codes, especially in Python language. I wanted a code of giving a graph of earthquakes happened in Turkey for last 10 days, and pasted it to VS Code. Here, let's see how GPT explains its own code. In the provided Python script, we embark on a journey to visualize the earthquake activity in Turkey over the last 10 days. The script unfolds in a series of well-orchestrated steps, each designed to guide us through the process from data acquisition to visualization, seamlessly integrating various Python libraries to achieve our goal. Here's a summary of how the script works. Importing essential libraries. We start by importing libraries that form the backbone of our script, requests for fetching data from the web, pandas for data organization and analysis, and matplotlib for graphing our findings. Additionally, we utilize datetime and time delta for handling dates, crucial for defining our 10-day window. Defining the data query. The script calculates the start date as 10 days prior to the current date to create a time frame for our earthquake data retrieval. Using this date, we construct a URL to query the USGS Earthquake API, specifying our time frame and the geographical bounds that encapsulate Turkey. This ensures we only fetch relevant earthquake data. Fetching and passing the data through a GET request to the USGS API, the script retrieves the earthquake data, which is returned in JSON format. This data includes details of various earthquakes, such as their time of occurrence, magnitude, and location. Data manipulation. With the raw data in hand, we transition to organizing and preparing it for visualization. We extract key pieces of information and structure them into a pandas data frame. This involves converting timestamps from milliseconds to a human-readable format and organizing the earthquake events into a tabular structure, facilitating easier analysis. Plotting the data. Finally, the script employs matplotlib to plot the data. It creates a scatter plot that maps out each earthquake's occurrence over time against its magnitude, offering a visual representation of earthquake activity in Turkey over the specified period. In essence, this script is a comprehensive guide to fetching, processing, and visualizing real-time earthquake data, showcasing the practical application of Python in analyzing and interpreting real-world phenomena. As this is the result, it gave what I wanted from him in a quiet, pure, and a simple way. For today, that's it. See you in another video. Never stop researching about the technology. You can see another video on screen, and you may want to watch it. See you in the next video.